Welcome back to the lab. Welcome back to EE for everyone. Today we're going to discuss the resistance and power regulation modes that we just tested on the electronic load. Why group these two measurements together? Why group these two sets of data together? Well, both of these measurement types take in voltage as an input, and they use that to compute the correct current output. That is certainly true, but not necessarily the best. So why are we doing this? Well, because we just tested the current accuracy, and we know the current accuracy gets worse, spectacularly bad, you might say, as currents get smaller towards 0.1 amps. Small currents aren't super accurate. Well, since we aren't doing any calibration to reel this in, we know that we'll have some errors when trying to drive small currents, and that'll be stacked on top of, actually multiplied with, all of the errors that we're adding by measuring the voltage. So we're basically taking the two sets of inaccuracies, multiplying them together, and, well, yeah, we're going to see all that in the current output, or the power and resistance output. Believe it or not, this is an important part of any project, known in some circles as setting expectations, or in others as lowering it. So in our live stream, the live stream that we just did recently, by the way, check out the archive if you haven't seen it, but we did a little testing for power regulation. Let's talk about that. Basically, we set the power to 30 watts, and then we ranged the input voltage from 7.3 to 32 volts. We're testing how well it can regulate a particular power set point across varying voltage. Why did we stop at 7 volts? Because our lab power supply, as always, is limited to 6 amps, unfortunately, and performance was mediocre, as you can see in this graph. The voltage measurement accuracy in general hasn't been that great. That could be in part due to the relatively high resistance, series resistance in that circuit before it gets to the ADC. Perhaps an op-amp buffer could help this out, but yeah, just need to drive with a low impedance. I don't know. We'll get to that in a moment. We'll find out more soon. The voltage measurement error didn't do us any favors, especially at lower voltages, ranging from at worst 40% error. At higher voltages, the error drops off, but unfortunately that's where the accuracy of the current regulation starts to get in the way, where we end up with this U-shaped error curve, where at low voltages we have high currents and the voltage accuracy drives in, and then at the lower currents due to the higher voltages we have low accuracy as well. Yeah, so we're not seeing the right hand of the U in this plot just because we ran out of voltage in our lab power supply, but maybe that means it's time to get a better one or another one or something. But let's transition to resistance. Let's talk about the resistance measurements as well. Resistors are cool. Resistance regulation is also cool. In fact, it's so cool that we fundamentally end up multiplying the error of the low voltages and the low current at the same time. Super cool. That means that we just turned our awesome U-shaped error curve into a mountain, just a super steep slope of incredibly bad error at low voltages. Yeah, when we had a 3 volt input trying to regulate to 6 ohms, half an amp out, 180% error is what we saw. 180% error. 180%. That's bad. That's the worst I've seen in a while. Yeah, 10 times 10 is still 100, unfortunately. You might be thinking, much like me, is this good enough? Do we need to make some improvements? It doesn't seem very good. And no, it's not very good. It's not great. This is garbage tier resistance and power regulation, just being honest. But here's the hope that I see in our future. Here's the hope that I see. If we improve voltage measurement accuracy at low voltages, and we improve the current accuracy at lower currents in our Proto 2 electronic load design, we could be in a very different set of circumstances. This could look very different in a couple days or weeks. I'm believing that we can and will do that. So let's circle back to this concept. Let's talk about the design changes and the improvement required to make our Proto 2 electronic load better than what we've tested today. We'll also be investigating the ripple of an off-the-shelf ATX power supply, but wait, why do we need an off-the-shelf ATX power supply? Well, better get subscribed so you don't miss out. If you like this video and you can't wait for more, let me know by getting subscribed, hitting that like button, or leaving a comment down below. If you'd like to support the channel, consider checking out our Patreon page linked in the description. It really helps out a lot, so thank you. Thank you to everyone who's taken that step of becoming a member, and honestly, anyone who supported us in any way. Thank you for those that watch, comment, like, anything that you do to support EE for Everyone. Thank you. You're a big part of making and keeping great projects like this one possible. If you're looking for something else to watch, don't forget to check out our live stream. Most of all, I hope that you learned something great today, and I hope to see you again soon. Thank you for watching EE for Everyone, and thanks for staying till the end. Bye!